let's get into the big topic of open source, something that we actually say at Red Hat.
This is so awesome.
We are an open culture that believes
actually
in
a big
importance
piece
of
of
Is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am co-host Mr. Andrew Sullivan, joined by, as always, by my lovely co-host Mr. Jonny Rickard. How are you today, sir?
I'm good, Mr. Co-host. How are you today?
It is a stunningly beautiful day outside. I am sad to say that I'm trapped in the house. I've been doing most of my work from the back porch this morning, so it's been pretty amazing.
That's awesome. Yeah, it's finally starting to cool down here. I think it's like in the 90s in the afternoon or something like that. So it's finally getting to where it's not miserable outside.
Yeah, I'm not ashamed to say that I sat outside last night by the fire pit and enjoyed a nice glass of whiskey and just relaxed last evening. It was
Nice.
pretty amazing. Yeah, I love the
Sometimes you
cooler
need
weather.
that.
Fall is a great time of year, right? And not just because everything is pumpkin spiced. So, it's, you know.
I agree. I think this in spring, like right as we transition into spring, where it's still nice and cold in the morning, but then it warms up in the afternoon.
Yeah.
Like that's my favorite time of year,
Yeah.
I think.
Yeah, but then here in Raleigh this weekend we've got a tropical event coming through. I think they're calling for like 2 inches of rain or something. So
Nice.
we'll see how that goes. I'm supposed to go to Red Hat Amphitheater for a concert on Saturday, so we'll see how that goes. It might be a little wet,
Yeah.
but
Well, who are you going to see?
oh gosh, I don't remember.
Taylor Swift?
I wish. Man. That's an event right there. I
know,
saw
man.
a news story not long ago that was saying that like the average Swiftie spends like $1,300 or $1,500 to go to a concert between
Yeah.
travel and tickets and merch and everything else. And yeah, that's impressive.
Band. Yeah.
I saw, I don't remember which city it was. One of the cities that recently hosted a Super Bowl said that she had a similar effect on the local economy that the Super Bowl did. Like, that's crazy.
Dang.
So, yeah.
Wow, that's awesome. Good for her.
Yeah. Well, enough of us rambling. So, hello, everyone. Welcome to this week's stream. So this is one of the office hours live streams here on Red Hat Live Streaming, which means that we are here for you all. We're here to answer questions. We're here to talk about all of the different things relating to OpenShift and whether it's admin stuff or dev stuff, although I admit that Mr. Rickard, Jonny and I don't know a whole lot about development, but we do our best. But yeah, today's topic is something that I think everyone is interested in. It's something that comes up regularly. I see constant questions in email and chat and all of the other places. I was just looking at the Kubernetes Slack. Like, there's always questions about performance. And so we were super happy when this team of folks reached out to us and said, hey, we'd love to come on. We'd love to talk about Kube-burner and the stuff that we've got going on. So I am very happy, and I know Jonny is as well, to welcome the Performance and Scale team. I think I'm saying that right, to the live stream, and that is Sai, Vishnu, and Raul. So I will ask you all to introduce yourselves in that order, if you don't mind.
Hello, everybody. I'm Sai Malani, and I'm an engineering manager. So I lead the Performance and Scale team here at Red Hat, focusing on OpenShift specifically. And my team does a lot of work on OpenShift Performance and Scale. Obviously, it's about scaling the cluster to its limits. And to support our mission, we work very closely with the product management teams, the engineering teams, the QE teams, and customer-facing teams. And in that process, build robust and maintainable open source tooling. That's where Kube-burner really comes into the picture, right? Our vision is to establish the performance and scale leadership of Red Hat's portfolio, and specifically OpenShift. And Kube-burner is helping us achieve that, not just by performance and scale testing new features, but also continuous automated regression testing of performance to ensure that OpenShift meets the rigor that customers have come to expect of Red Hat's products. So stability, security, performance, three of the most important non-functional requirements. And I'm proud to say that the work that my team does on performance is helping Red Hat and OpenShift stand out as an industry leader. With that, I'll I'm also one of the main contributors of Kube-burner, so I'm here in that capacity today, and I'll pass on to the maintainers of Kube-burner, Vishnu and Raul. Raul is also the creator of Kube-burner, by the way.
Okay, I'll go first. Hello, everyone. My name is Vishnu Challa. I've been with Red Hat since I think for 10 months. I've been having a great time over here. As a software engineer, my areas of interest are large-scale distributed systems. So, I keep spending a lot of my leisure time in reading articles and, going to stuff and experimenting things. And Kube-burner is one of my area of interest in performance and scale engineering. And as I mentioned, our team primarily focused on, scale testing and performance testing, OpenShift, and some of our other products too, which are internal to Red Hat. And that's pretty much about it. And apart from work, my areas of interest are like I like triathlete formats, and these days I've been planning to attend some of the music concerts as well. Yeah, I'll pass it on to Raul.
Okay, thank you, Vishnu. Hello, everyone. This is Raul Sevilla. I'm a performance engineer since I think it's 2020. Well, actually, I joined late 2019, just before the pandemic outbreak, and I have been working for Red Hat for 7 years now, for more than 7 years now, and well, I am working as a principal performance and scale engineer, and I decided to create Kube-burner in summer 2020. So I have been the main maintainer since that moment. With the latest events, we have seen growth of Kube-burner across the community, and this is one of the reasons we have decided to introduce this tool to a wider audience, so it can be more helpful to all the people.
Yeah. Thank you all. It's really helpful and insightful. And Vishnu, welcome to Red Hat.
Indeed.
10 months, I'm sure that flies by. One of the people on my team just passed 1 year yesterday. So, but I like what you said, Sai, there of performance regression, right? It's a huge thing. It's something that we definitely want to avoid in many different ways. I always look at it similar to what Jonny's team does with the validated patterns of we want to constantly have testing going on to validate and verify that, hey, we added this new cool thing, or we fixed this bug, and we didn't introduce something new or something different or unexpected. Rather, it's we can plan for those things. We find those things as early as possible and either fix them or prepare our users for what the changes might be.
Let everyone know.
Yeah, this thing's always changing, right? The HA proxy version changes, going from one OpenShift version to another. That may or may not have an impact on your Ingress performance. Or in some cases, the RHEL major version might change. So we do a lot of work to catch these things early. So operating as left as possible, right? So.
Yep, and I know I reference the presentations that your team does regularly inside of many of my conversations.
Oh, thank you.
Yeah,
so no, thank you.
Thank you. All right, Jonny, let's churn through some top of mind stuff here real quick, and then we can get to today's topic.
Yep.
Let's see. You want to start?
Yeah, I'll just go. Mine are going to be quick. So just again, reminder for everybody that there's going to be some API deprecations in OpenShift 4.14. So just kind of keep your eyes open for that. I did see a blog about the different releases or about the different features that are coming out in Kubernetes 128. So I will review that, and then next week we'll talk about it. And then ACS 4.2 was released. Also, there's a cloud version that's if you wanted to kick the tires, right? Go through a trial run of it. I'll post a link here in just a moment, but yeah, basically you can go out and you can try the cloud-based ACS for a little while. And then there was an announcement earlier today or yesterday, I think, about OpenStack services are now going to be available for telco on OpenShift, which is going to be a pretty big deal. That's kind of cool. And then finally, what's new in OpenShift is going to be October 12th at 10 Eastern to 11:30 Eastern. So if you want to join, Andrew and I are usually there in the background answering questions. So again, October 12th, 10 to 11:30 Eastern. And then finally, for me, the upcoming schedule is next week. We got the man, the myth, the legend, Ortwin coming on to talk about all things service mesh. And then in October, it's all about security and security and OpenShift and Kubernetes. So we're going to have vulnerability and configuration management, runtime security, and then CI/CD pipeline security. So action-packed couple months coming up, and it's going to be amazing.
Yeah, quite the build-up, quite the lead into KubeCon happening there in early November, I think it is.
Yep.
I honestly haven't looked to see because I'm not going. I wish I was going. I haven't been to a KubeCon in a couple of years. But yeah, we'll see. So yeah, thank you. Let's see, what did I have on here? I had a couple of things. So two things came up in conversations recently. So the first one, I'm going to share my screen here because that's going to be the easiest way to talk about it. Share this guy. So the first thing that I want to bring up here is the high availability flag that's set when deploying a cluster. So there's kind of two deployment models for OpenShift, right? There is the traditional 3 or more node cluster deployment. So I have a compact cluster, so it's 3 nodes where all the nodes are both control plane and worker nodes. And then I have 5 node clusters. So 3 control plane nodes, 2 worker nodes. And then the other side is either single node OpenShift or a cluster where there is only 1 worker node. So for example, it's possible to deploy a cluster that has 3 control plane nodes and a single worker node. When you do either one of those latter deployment models or cluster architectures, what it does is it changes this flag, right, this infrastructure topology, to be single replica. So what does that actually mean? So that flag is used by various operators that make up OpenShift in order to identify and determine kind of what is the availability constraints that I have available to me. So for example, with the ingress controller, right? So the HA proxy based ingress for bringing traffic into OpenShift, if it's set to highly available, the default number of replicas is going to be 2. Right? There's 2 worker nodes or 2 some kind of node that is there, so it can deploy 2 instances and provide high availability. However, if it's set to single replica or non-highly available, it will set that value to 1. So why is this potentially an issue? So 1, you cannot change this value after deployment. So if I deploy a single node OpenShift, it's going to set it to single replica, even if I add worker nodes day 2. So now I have 2 or 3 or 5 worker nodes joined to that single node OpenShift. It will still say single replica. It won't switch over to highly available. Generally speaking, this isn't an issue. Most of those operators that you can go in, you can change them. So like I said, the ingress operator, you can go in day 2 after you add those worker nodes and scale up the number of replicas to provide high availability. Probably the most important one is OpenShift virtualization. When OpenShift virtualization sees this single replica setting, it disables live migration. And you cannot re-enable that, right? You cannot change that single replica value. So just keep that in mind if you're doing OpenShift virtualization, if you're using single node OpenShift, planning on adding worker nodes afterwards. I'll also point out that this doesn't change, quote unquote, the high availability of workloads inside the cluster. So if you deploy single node OpenShift and then you add some worker nodes, if one of those worker nodes were to fail, it's going to reschedule those failed pods just like always, right? It doesn't change any of the behavior in that respect. So the other thing that I will quickly point out is this came from a conversation, and actually, Sai and company, you might be a good crowd to add in some comments if they come to mind. So somebody was asking about actually the number of routes that are supported by the HA proxy-based ingress, right? I think by default, and if we come down here, come on, mouse. If we scroll down through here to scalability and performance.
I think what we test is 2,000 per shard.
Yeah.
That should, Yep.
So if we look down here, right, 2,000 per shard. So the question was, why hasn't this changed in however many versions? Why is it not supported to put 2001 on there or something like that? And the response to that is, interestingly, well, it's not unsupported, right? There's nothing that says that you can't put 5,000 or 10,000 or 50,000 different routes on each one of these routers. And support, once you exceed that number, will do their best to help you as much as they possibly can. The difference is we know that up to 2,000 per router is going to work. We test that, as I said. So we generally know exactly what to expect, what the limitations are, when there might be issues, right? Barring edge cases and stuff like that. And so that's also what they engineer against. So if you put 10,000 inside of there, it might work perfectly fine. There might not be any issues, and it'll do exactly what you expect it to do. And you'll never have to pick up the phone and call us. But it might not. You might encounter some, edge case that we've never encountered before, and support's response might be, well, I'm sorry, your best option right now is to reduce it to 2,000 per router or fewer. Conversely, as I said, there are sometimes edge cases. Maybe you only have 500 routes on that router, but they're constantly changing and churning, which is causing HA proxy to constantly have to reload, and it results in that router not being able to support up to 2,000. So the little secret behind the scenes there is, so the HA proxy config is reloaded every time one of those routes changes. So what causes a route change, right? Clearly doing something like creating a new route or just deleting a route, modifying services, the pods. So let's say I've got a route that has 1,000 pods that it's pointing to. If those pods are constantly bouncing around up and down, it's having to change. It's having to update that route config to know where to direct that traffic to. So that can cause that number of routes per router to be lower than you might expect. So just something to keep in mind. And this is true of a lot of different things inside of here, right? The number of secrets. We test up to 80,000. That doesn't mean that as soon as you reach 80,001, your cluster is unsupported. It just means that,
Yes.
Yeah, there might be some things that happen that we aren't aware of, and we'll do our best to help you. But you might, as the saying goes, here might be dragons.
Yeah, I've actually met a lot of customers that have more secrets than that, but you're spot on, Andrew. I think you should come join us in performance engineering. You seem to have a natural knack for it.
I will very happily admit that I used to do a lot of performance testing when I was a storage admin, as you might expect. But anyways. That's all I got. Jonny covered the vast majority of things, so I just wanted to hit on those 2 quick points because I think it's important, particularly for this tested maximums, right? Tested does not mean the same thing as the floor or ceiling, as the case may be for supported. All right, with that, we have consumed more than enough time. So please feel free to ask any questions that are that come to mind. Ask those in the chat. Anything that you would like, whether it's about performance and scale, whether it's about OpenShift, we'll do our best to answer all of those questions. If you aren't watching us live, I know a lot of people like to listen to the recordings. You can also feel free to reach out to us afterwards, and we will be more than happy to answer those questions to the best of our ability. So for reference, you can reach out to, I can never find the button that I'm looking for when I want to find it. You can reach out to me at andrew.sullivan@redhat.com or on the various social platforms at practicalandrew. Or you can reach out to Jonny via email at Jonny, Jonny, no H, at redhat.com or jrocktx1 across all the various social platforms. And with that, I'm going to hand it over to you, Sai. So performance and scale. I know that you all have a couple of things to show us. So I'm excited to see and learn more about Kube-burner. Like I know the concept, I know what it does, but I don't know details.
Awesome. So why don't we just do a quick slideshow and just jump into demos? Does that work?
Sounds great. I love demos.
Awesome. So again, we've just introduced ourselves, so I don't feel the need to do it again, but we're going to talk about Kube-burner. And what is Kube-burner, right? The one-line summary is it's a Kubernetes performance and scale test orchestration framework, right? We use it against OpenShift, but it's more than that. We can run it against vanilla Kubernetes, against different distros of Kubernetes, but the work that my team does primarily is focused on OpenShift. And there's a few pieces to its functionality, right? One is its ability to create, read, update, and delete Kubernetes resources at scale. So it helps us test the cluster to its limits. It is also able to go and collect Prometheus metrics while we run these tests and index them into something that's more of a longer term storage like Elasticsearch or OpenSearch. It also has some custom measurements that it does by its own, like how long does a pod take to go into ready. You're also able to have customer expressions to alert you while this workload is running, if etcd is seeing leader changes or anything funky is happening on the cluster, so you'll be able to get those alerts. So it has multiple pieces to its functionality, but at the core, it's a Kubernetes performance and scale test orchestration framework. And
so you said something there that I think might be important: orchestration framework, in that it's coordinating and orchestrating the workload and the collection of metrics, but it itself is not necessarily creating the workload. That's where us come in as that performance engineer.
Right. It also has some canned scenarios that you're able to run. So it creates the workload. It creates the workload, it tears it down, it indexes the metrics, but it's also able to take care of the orchestration. You have the power to define what the workload should look like, if that makes sense.
It does. And I want to point out that it's very good that there is canned workload available. But, a lot of times, I respond to a lot of customers of like, oh, what does it mean when I do this? There's actually an open thread somewhere inside of Red Hat about, the difference between OpenShift Java-based applications hosted in OpenShift on bare metal versus virtualization. And it's one of those, like, there's so many factors there. We can't predict that. You need to do your own performance testing and validation. And I think that this is a great framework, a great tool to help with that.
We have various success stories where we've used this tool to give customers data, but not just that, right? Empowered customers to model their own workloads and see how they fare. So, yeah. All right. With that, I will just... Why do we need Kube-burner, right? Some of the questions that we're trying to answer with Kube-burner: how big can my cluster be for this workload, right? Is 50 nodes too much? Can I go up to 250? How many pods per node can I run at the maximum? This has been like a hot topic, right? You must have noticed in the OpenShift documentation that it used to say 250 back in the day, and it's still 250 out of the box, but we've done several experiments using Kube-burner to prove that you can go all the way up to 2,500 pods per node. Again, your mileage might vary. There are a lot of conditions you have to satisfy. You have to keep monitoring the load on the system. But like everything with performance, it's subjective. But Kube-burner has helped us model that workload and push the runtime to the limits. How many CRDs can my cluster handle? This is related to one of the questions we see on chat. How many operators can my cluster handle? Which is related to how many CRDs you can throw on the control plane there, right? How long does the CNI plugin, OVN Kubernetes or OpenShift SDN, how long does it really take to program those flows? How many services can I create? Is 5,000 too many? Does it matter if it's a node port or cluster IP type of service? Is Kubernetes getting better with each release, or is it getting worse? Has there been any performance degradation when we bump the etcd version? So all of these questions, they come to mind, and Kube-burner is one Swiss Army knife that can help you answer some of these questions. And it's not just for performance engineers. I think if you look at it, the different personas, if you're an architect and if you want to figure out what the cluster sizing should be like, and if you want to do some capacity planning or establish some SLOs that are actually tangible and real, you can use Kube-burner to do that. As an admin, you want to know what the baseline performance of your cluster is, right? What are the SLIs looking like? And Kube-burner can help you with some of that. As an app developer, you want to set some expectations from platforms, and you want to see if that's being met in the cloud native world. So it can also help that persona.
So
with that, go ahead.
Oh, sorry. I was going to say, from my experience as an architect, like all of your questions are questions that we probably answer 100 times over with each customer, right? Like when we're talking to the various groups within the customer organization, like I feel like we go through this stuff every week. And then like I think you've nailed it with like who this is actually for. It's not just engineering, right? It's actually for these different groups because they have to know. But then my question is, I know you're doing a lot of this with OpenShift and stuff like that, but are you contributing this back to like upstream Kubernetes? Like is Kubernetes project or the umbrella, the CNCF umbrella, using this at all?
So there is a proposal in progress. So we have a CNCF sandbox application already in flight. But yes, our primary testing is on OpenShift. We actually have Kube-burner running in Prow jobs, but I am pretty sure people are using this to run it against vanilla Kubernetes. And for example, our CI is based on kind, right? So we run it against vanilla Kubernetes. But if you're asking about directly plugging into the pipelines in Kubernetes, I don't believe we are doing that today, but we have plans to get there, and that's what the CNCF sandbox proposal is about.
That's awesome. That's awesome.
All right, I'll pass it off to, I think, Vishnu.
All right, thanks, Sai. Now, at this moment, you might be having questions on how does Kube-burner work, like how it actually manages to connect to the cluster, how it actually creates resources and triggers a workload, and how it scrapes the metrics and publishes them or indexes them to a desired destination. So in order to answer these questions, here is the slide. So we ship all our source code in the form of a Go binary, like executable binary, which is available for all architectures. And these are some of the libraries which we extensively use in our source code. One is client grow. So using this library, we manage to connect to the cluster using kubeconfig, and also we make API endpoint hits to API server endpoints. So these hits help us to trigger the resources and manage them throughout the lifecycle and throughout the workload. And we also make use of Prometheus Go client, which helps us to connect to any Prometheus. Not only, it need not necessarily be to the cluster Prometheus in order to scrape the metrics. And also we run a set of queries to make sure like we capture all the metrics during the workload runtime, and also we make a record of them. So with this,
Just as a side note, we haven't mentioned it here. It is also compatible with Thanos API.
yep. And also Kube-burner currently supports all kinds of K8s distributions because it uses some of the base core libraries in order to do its operations. It can support K8s, any K8s distribution like Kind or in any Kubernetes cluster, or also OpenShift cluster as well. But most of our activity is involved in an OpenShift cluster. So few more points about Kube-burner are like it is very easy to play around with. You just need to specify a YML file as an input configuration, and Kube-burner is the one which consumes it and then triggers the workload based upon the configuration parameters specified. And also once we have the workload triggered and run, we capture the measurement, and then we also capture some of the cluster Prometheus metrics in order to look at the cluster performance during the workload. And once we have all those metrics ready, we index them to our indexers, which can either be a local file system or else a remote indexer like OpenShift or Elasticsearch. So here is an overview on the Kube-burner workflow. So here is where it starts. So for example, if you look at the first step is Kube-burner would be the entry point, and we'll be specifying a YML file as an input configuration. So it reads the YML file, keeps it in memory, and based upon the configurations which we specify over there, it creates the resources first. Once the resources are created, Kube-burner manages to identify the resources which are created as a part of workload, ignoring the rest of them in the cluster, and then triggers measurements on top of it. It kind of keeps a watcher on top of those resources to as a starting point to capture the measurements. So once that is done, it triggers the workload and waits for the expected state to be reached. For example, if we have a set of pods being spinned up, it waits for pods to get ready. And also we have a custom feature of specifying our own condition for termination. For example, if you want to specify some like wait until pods reach container steady state, it can wait till there and then stop measurements and then take it forward. So once it reaches the expected state of the workload, then we stop our measurements on all the resources, perform some statistic calculations on top of them in order to gather latencies, pprof metrics, or any other metrics which we specify. And once we have those metrics, we also make sure we scrape cluster Prometheus metrics as well. So during this workload trigger period, we make a note of start and end time. And during those time periods, we run a bunch of queries on cluster Prometheus, which basically help us indicate and evaluate cluster performance during the workload was ran. So once we have all these runtime metrics as well as cluster metrics ready, we manage them to index to our indexers. So currently we have three types of indexers supported: OpenSearch, Elasticsearch, as well as local indexer. Local indexer is nothing but we index those metrics into our local file system in JSON format. And also along with the alerting feature, along with the scraping feature, we also have some alerting feature that can be configured, wherein we specify a set of configuration to trigger, based upon thresholds, we trigger alerts, and then we can also make a note of those alerts. So for example, by we're just looking at the metrics, might not be able to, grasp all that information at once, but having these alerts configured, it will help us to, immediately look at what we actually were expecting to look at. So for example, if we have set like, pod latency threshold of, these many seconds, if there is a breach in that alert, it will immediately drop us an alert and we can take a look at it instead of going through the entire metrics. So this is a brief overview on how the benchmark triggers. And currently we support 3 types of job. One is create, delete, and the other one is patch. So in create job, it reads the configuration file and creates all the resources, triggers workload on top of them, and then collects the metrics and publishes through the desired indexer, like the workflow indicates below. When it comes to delete job, it identifies all the resources based upon the labels we have specified, label selectors, and then deletes them. And when it comes to patch job, does follow the same pattern of identifying all the resources based upon label selectors and applies the patches which we specify through the configuration file. So with these 3 kind of jobs, we can trigger the workload and as well as monitor the metrics during that point in time. Next, I would hand over to Raul.
Cool. Thanks, Vishnu. So regarding Kube-burner performance measurements, that is something that Vishnu already mentioned. The difference between Kube-burner measurements and the kind of the standard Prometheus metrics is that these measurements do not have any need of having a Prometheus instance running on top of your cluster. These kind of measurements are directly taken from data points obtained from the API or other subsystems. At the moment, we are supporting 3 different types of measurements, which are basically pod latency, VMI latency, and pprof metrics. The first 2, the pod and VMI latency, are meant to measure and provide the latency of the different life cycles events of these kind of resources. In case of VMI, in case you don't know, VMI, it refers to virtual machine instance, which is a special object for the Kube platform, or CMV in the case of OpenShift virtualization, in case of OpenShift. And regarding pprof measurement, it makes Kube-burner able to scrape different pods designed by a set of labels and selectors to obtain the pprof information. Pprof, which is our memory, heap, CPU profiles, and mutex profiles from the Golang applications running on top of your cluster in form of within pods. And the resulting data is stored in a local directory in pprof format, and we can use that data to plot nice flame graphs or analyze or deep analyze if there has been any kind of memory leak or something like that in any kind of application running, any kind of Golang application running in OpenShift. This is mainly meant to be triggered against control plane components of OpenShift or Kubernetes, like a scheduler, Kube API, and etcd. So next slide.
And I would imagine all of these measurements are used in conjunction with what, for example, etcd's own performance reporting is doing. So as we ramp up and add more objects or more activity happening in the cluster, we also compare that against what was happening in etcd at the same time, so we can get that idea of.
Yeah, imagine this case. Imagine we have detected that etcd memory usage has grown a lot in a new version of OpenShift, and we have been asked by the etcd team to figure out where that memory usage is coming from. So one way, apart from counting the number of keys and investigating some of the database content in etcd, would be to get a pprof during a workload, so we can see what internal Golang structures have grown during this new version. So it's low-level debugging, but it has resulted
Yeah.
useful in some occasions.
Well, I would imagine it's, at a higher level, it can also be useful for things like, we regularly get asked, my storage latency is X milliseconds. What does that mean? Or my network latency between control plane nodes, what does that mean for the cluster? Well, the higher etcd latency is, then generally speaking, the lower the scalability is. So a tool like this,
Yeah.
where we can generate that workload, that activity against etcd, helps us to gauge and understand for your specific instance where you have these constraints, what might that actual scalability limit
Yeah,
be?
exactly. In our group, we used to say that every object has performance impact, regardless that object is a complex object like a CRT or something like a CD config map doing anything. Because every object is stored in etcd and could be potentially listed by the API and that is going to consume some CPU cycles and also some block IO cycles as well. Regarding next slide, metrics collection and indexing and alerting, just saying that Kubernetes is able to collect metrics using ProQL expressions. And as Vishnu said, it is capable of indexing them in an external indexer. Supported ones are Elasticsearch. We are also using OpenSearch, which is also offered by AWS. And we are also supporting JSON files, which can be useful at the time of executing Kube-burner in disconnected environments. In case, for example, the client machine where you're executing Kube-burner from doesn't have a direct access to any kind of Elasticsearch or OpenSearch instance. You can basically set those files into JSON and import them later from a connected environment. And yeah, supported sources for scraping are Prometheus and Thanos. And we also support scraping for multiple endpoints. That is to say that if, for example, your cluster have a couple of monitoring stacks, let's say you have the user monitoring stack set up in your environment, Kube-burner is also able to scrape from the main Prometheus instance and also from the user monitoring stack instance. And yeah, Kube-burner is also able to generate a tarball containing all the metrics so that we can import them later in a connected environment.
Yeah, I think that kind of brings us to the brief overview we want to do in terms of a slide deck, which should give us some time to get into the fun part, which is the demos. If that's okay with you, Andrew and Jonny, or if you want to shoot a few questions before that, that's totally fine too.
That sounds great, so long as your demos are not as disastrous as Johnny's.
Yeah, please. Hopefully you just tested them before you go live like I do. So
yeah, we had 5 demos. Go ahead, Raul.
Last quick thing, sorry, I forgot to talk about the alerting feature. So alerting feature is something kind of similar to Prometheus alerting. It is basically a feature that makes Kube-burner able to read something we call alert profile. And into that metric profile is just an array, a list of Prometheus expressions. And Kube-burner will take care of reading those Prometheus expressions, executing them into the selected Prometheus endpoint, and get the result of those expressions. So, for example, we can check if we can verify if all these services have been available or during a certain amount of time of the workload, or maybe we can even execute check alerts for a custom range of time. But that is something we will cover later.
Yeah, API availability and stuff during the workload, we could just get an alert that says, hey, your API was not available for X amount of duration. So we have some demos planned, like I said. We may not have time to get through everything, so we'll probably get through a few of them. We had 5 demos planned. We probably will hope to get through at least 3 of them.
Awesome.
All right, so hopefully my screen sharing works. So I'm gonna start with the bare bones. Is my font big enough? Or hopefully it's big enough.
I think so.
Okay.
The audience will let us know if it's too hard to read.
Okay. So I'll start with the bare bones functionality, and we'll build up through a series of demos to the full functionality. And what I'm going to show is the basic subcommand, right? The init subcommand. It is the entry point for Kube-burner to launch benchmarks. And the only argument it really expects is a config file, which really gives you a lot of control over what you want defined to be run by Kube-burner. The UUID argument is optional. If you don't pass something, it will just auto-generate it. And the reason we need this is Kube-burner is going to label all the resources it creates with this UUID. So it's easy for you to identify what Kube-burner created versus what something else created. So this is the basic functionality. It creates resources. It's able to delete resources. We'll look at what the config file looks like. And before that, what am I trying to really do here? I'm trying to create 10 namespaces, each of them having 3 deployments, and each deployment having 1 replica of an Nginx pod. So that's really what I'm trying to do here. And the Kube-burner config file is divided into a series of jobs. You can have multiple jobs in a list. I only have 1 job here, right? That's what the jobs keyword here denotes. And there are some global options here like GC true, which means, hey, Kube-burner, you should clean up after yourself. Go garbage collect everything you've created. So that's something you can set to false or true. In the interest of time, I will actually set it to true so that it can clean up after itself, or we'll see.
That's very responsible of you.
Yeah, thank you. So let's just look at the job configuration, right? It's just the name of the job, the Ask OCP Admin, have that special name for you guys. What is this prefix of the namespaces you want to create? Ask OCP Admin will be the prefix. I want 10 iterations, which means create 10 namespaces. QPS and burst are client go parameters that determine the rate at which Kube-burner operates against the Kubernetes API. So it's basically creating 5 objects per second. Namespace iterations means for every job iteration, create a new namespace. So your namespaces are going to look like Ask OCP Admin 0, 1, 2, 3. So it's going to spread things out. Wait when finished. True means wait for all the pods to be running so you can finish the measurement of how long it took for a pod to be ready. Preload images. True means the first container running on a particular node is always going to take more time because you need to do the image download, right? And that will screw up our measurement. So what this tells Kube-burner is just create a daemon set with this images that all the images you're going to use in this run, and make sure they're running before you run the actual workload. A lot of this is boilerplate. You don't necessarily have to define all of these when you run this config file. We will assume safe defaults as needed. The real thing that's happening here is creating 3 objects. Well, the objects list. We are only creating deployment, 3 deployments per namespace across 10 namespaces, right? And the replicas argument here is specific to Kube-burner. It does not denote the replicas of the deployment. It's how many replicas of the object Kube-burner is creating you want, right? And it's going to use this template to create it. Let's take a look at that template real quick to see what it's really just an Nginx deployment with replica 1. Some of these variables like replica are injected by Kube-burner to uniquely distinguish the different deployments it's going to create. Remember, it creates 3 deployments per namespace. Every deployment needs to have a unique name, right? So it's going to just inject this automated variable, which is replica, and you can use that. And all of this happens through Ghost templating language. So to do that, I have my nice little Rosa cluster, right, sitting in the cloud with 3 infra nodes, 3 master, 3 worker nodes. Let's see what Kube-burner init is going to do when I run this. So it's starting Kube-burner. It's doing the preload of the images, right? I want to do some measurements along how long it took for the pod to go through scheduling all the way to containers ready. So for that, I don't want to skew the measurements. So the first one is being created as a daemon set across all the worker nodes available on the cluster. Then it's deleting that, and it's running those job iterations, right? 10 namespaces. It's going to go and create it. I asked for it to check that all the pods were created. So it's going through and doing that as we speak. And I think I said GC equals to true. Yeah, I think I left GC equals to true. So it's cleaning up after itself. But if I had GC set to false, I would have to use a different command, which is called Kube-burner destroy, to go through and destroy all the namespaces that it created. Let's wait for this to finish here in a second. But any questions while we see this and while we have it wait for it to complete?
I just think that this is fascinating for a number of different reasons. One, it's very straightforward, right? It's YAML. It's the same sort of templating language that we're used to across, multiple other Red Hat, I'll say products, and projects and stuff like that. So it's very straightforward to look and to see exactly what's going to happen inside of there.
Yeah.
I'm
just
wondering
say
if
it did complete.
Yeah. Oh, yeah. So I'm wondering is there any sort of built-in graphing or reporting, charting type of thing, or is that kind of up to the user?
No, this is the bare bones functionality. Raul and Vishnu will build into this functionality because we scrape all of these measurements and metrics and ship it to Elasticsearch. And we could just have a Grafana front end hooked into that backend to graph all of this stuff. So I'm going to pass it off to Vishnu in the interest of time. But yeah, I had GC set to true. I forgot to say false. But if I had GC set to false, I would have, Kube-burner destroy, pass it the UUID. But now since we had GC set to true, I can't really show you all the namespaces with the resources. That was my intent. It's never a demo if it just goes perfectly as you plan. So.
Oh, don't I know that? So.
Yeah.
But you can see in the output there that you've got your namespaces. If you look in the middle of the, I'm pointing to my screen, like you can see what I'm pointing at. But like, yeah, if you look in the middle of your output, you can see the different namespaces I got created.
Yeah. So I'm not going to sweat it, but I'll pass it off to Vishnu and he can take over the next demo.
Yeah, sure. Let me share my screen. Is my screen visible? Oh, yes.
We're in Restream Inception. There you go.
Yeah, so I'll be demonstrating a different option here. So I'll be demonstrating Kube-burner along with indexing. So this is how the configuration file looks like, which is similar to the previous boilerplate, which we took a look at. I'll just zoom in a little bit. Okay. So here is where we specify all our global parameters. We say GC is equal to true to garbage collect to enable the garbage collection step, as well as we specify the indexer configuration. So here we say it as local. That means to index all the metrics to our local file system. And also here we talk about measurements that needs to be calculated during the workload. So here we specify pod latency along with a threshold. So for example, if it breaches over a threshold of P99 greater than 10 seconds, it will drop us an alert. And along with that, this is the metric which is need to be calculated. Similar to pod latency, we can specify VM latency and pprof as we mentioned in the previous slides. And let's move on to the jobs part. So here is where the magic happens. Here is where we configure which, the name of the job, the type of the job. By default, it is create type. This job creates all the resources and triggers workload. And here is the namespace prefix. And here is 100 iterations of these objects. So this will be a generic template, and objects is something which user is empowered to play around with. It need not necessarily be a deployment and secret. It can either be a CRD and any API resource which is supported by Kubernetes. So it just does an operation which is similar to OC apply to just apply those, or kubectl apply to apply those resources on top of the cluster. So that's one more interesting aspect of this product. And this is QPS, which basically indicates the queries per second that Kube-burner can make to the API server to hit the endpoints and manage those resources, either create, patch, perform all the CRUD operations. And burst is an interesting feature. What it indicates is whenever there's a spike situation to the API server on the request being made, on how many maximum amount of requests to throttle on. For example, we are hitting API server with 10 QPS, and if there's a spike situation on the API server, it can throttle up to 10 more requests. And the remaining ones, it will try to manage, but if they fill up the work queue, they will eventually get timed out or failed. So that's the significance of this burst aspect. But most likely, if we set both of them too, it should be a smooth and peaceful run. And namespace iterations indicates whether to create each iteration in a single namespace or else create all the iterations in a single. Namespace. Yeah.
You froze for a moment, Vishnu.
But you're back.
Yes, you're back now.
Oh, okay. So yeah, I was just going to say when it comes to iterations, so here we say 100 iterations. So for each iteration, it deploys all these objects specified here. For example, deployment with 2 replicas and a secret with 1 replica. So we'll have 3 resources deployed for each iteration. So we specified 100 here. So 100 into 3, total 300 resources will be deployed on top of the cluster. And this is the preload step configuration, which was mentioned in the previous demo. Like it creates daemon sets and makes sure that all the images that are going to be used as a part of the workload are already ready before the workload is actually being triggered. So with all this configuration, let's go ahead and trigger the workload. And one more good thing about this, along with this configuration, we also managed to specify something called a metrics profile, which is nothing but has a set of Prometheus queries, which we were talking about capturing cluster Prometheus metrics after the workload, to check the performance and behavior of the cluster during the workload period. And this is the flexibility that a user can have. They can specify any query they want to check performance on top of any component. Maybe it's etcd, API server, or anything else, or Cryo, Kubelet, anything else. And yeah, with all these resources, let's go ahead and trigger it.
So while you're running that really quick, and this is just more of a general question. Like I know it's a project and this is a binary and stuff like that, right? Are you building this into an operator and going to deploy it as an operator, or is it always going to be something that you would just pull down and run kind of externally to the cluster?
So we usually, go ahead, sorry. So we usually generate a binary, and using that binary, we trigger our workloads. So when it comes to scale aspect, triggering it through a CI, we have some scripts, boiler like the template scripts, which manage to generate a configuration file template, which is designed by Kube-burner and triggers the workload through passing it as an input to the binary.
But to specifically answer your question, Jonny, there's a couple of reasons why we don't do the operator model, right? We can't really scale test a cluster when you're running the workload within the cluster, right?
Yeah, exactly.
If I break my cluster, I at least need to get the metrics and the symptoms and the root cause behind that. And I also don't want to spin up an entire new cluster to just run Kube-burner to operate against a different cluster.
Yeah, that makes
sense.
Yeah, it does. It totally does. Because as we were going through this, I was just kind of like asking myself, like, how would you know if it's the tool or the cluster if it's broken? So that's kind of like where my question was coming from. So then my next question is really more of a like future request thing, I guess maybe, or so are you guys going to generate like templated? I know you've got these templates for like your deployments and stuff like that, but like a GitHub Actions template or like a Tecton task template or something like that would have like this Kube-burner stuff in there. So that way, all you're doing is you're just dumping in params and then letting it go. Is that kind of like on the roadmap, or have you've probably already done it?
Yeah, we have.
Are you asking about modeling workloads that represent like a Tecton pipeline or something? Is that what you're asking?
No. Like, so say if I have OpenShift pipelines installed, and I want to run this, like, hey, I want to do a performance test of an application that I'm doing. Is there like are you guys going to generate like a task that's going to be public that I can pull down, and then I can just say, hey, here's the namespaces, here's the number, here's the bursting and stuff like that, and then go. You know what I mean? So that way it's just that reusability. This is just the nerd in me asking about that.
So we have some wrappers around. So two things. We have some canned scenarios that you can already use, and we have some wrapper scripts around Kube-burner that will just simply create that scenario for you against any cluster you want.
Okay, got it. Awesome.
So we just have to extract those templates and make tweaks on top of it if there is any custom configuration which someone designs.
Gotcha.
Yeah, so let's look at this run in detail. So here I just specified Kube-burner init command with the configuration file, which I talked about earlier, and the metrics profile file, which has a bunch of Prometheus queries to scrape at the end of workload, and Prometheus URL and token, as well as the log level. So here, since we have enabled debug logging, which is one more interesting feature, which you can look in detail, like what happened during the workload. So it just created an indexer object to index all our metrics. That's just creating a directory in the local file system, and then establish a connection with Prometheus, and then start the workload. So during workload, it just spins up some of the resources which we specify as a part of config file, and registers a measurement watcher on top of them, just to kind of keep track of those resources to calculate measurements on top of it. So once that is done, it spits out some information about configuration file, like the configured QPS, the resources which are being deployed, as well as the preload step going on here. Once that is done, it cleans up preload namespace and then starts creating all the resources which were desired as a part of workload. For example, if you look at this iteration, so it has three deployments created here, and also you should be able to spot some of the secrets which were also specified as a part of configuration file. So this uses multiprocessing to create all those resources. This kind of creates stress on top of the cluster by creating all those resources, and at the end, it makes sure all those resources are reaching to the expected end state, which is in our case ready state for the pods. So once that is done, that's what this parameter of wait when finished true means, to check for resources if they are in the ready state at the end. So once it reaches that state, it verifies the count of objects if it is expected or not. If it is not, it throws error in the command line with the exit status non-zero. And once it verifies all the resources are done, it stops the measurement factory and then calculates latencies here. So here is what it spits out, the pod latencies, and we have the same set of metrics indexed to our desired indexer as well. So these are some of the metrics, like how much time on an average pods took for to reach initialized state scheduled, containers ready, and ready state. So once we have all those metrics, it starts scraping all the metrics which are specified as a part of metrics profile on top of cluster Prometheus. So these are all the queries which are being run, and we have all those metrics calculated. Since we specified indexer as local, we should be able to find them in our local file system. So these are the metrics which are published in our local file system. So these are with the names which are specified in the metrics profile. For example, if someone wants to look at this 99th etcd diskwell fsync duration seconds, they can simply open up this JSON and look at the specific metric. And this is how the content of this JSON looks like.
It's important to point out that Vishnu in this specific demo was just, as we build through the demos, he was just pointing out the local indexing option. What we usually do for our work is use the remote open search feature, where we send all of these metrics that was scraped to an open search instance and actually visualize them through a front-end Grafana. That's our usual workflow as a performance engineer. And I think Raul's demo will touch on some of that.
Yeah, I think we have the same, as a second portion of my demo. So now that we have seen local indexing, we will trigger another workload, which basically triggers a workload and publishes all the metrics to Elasticsearch.
You might need to make that a little larger, Vishnu.
Oh, okay.
Vishnu, okay, let's see how much long it takes. Otherwise, I think Raul's demo also goes through the indexing feature, so maybe we could cover both of them in that, if that's something we can do.
Yeah, okay, it should be right away. Yeah, I think we can pass it over to Raul to go ahead with the indexing feature. Yeah.
Okay, let me try to share my screen in that case.
There we go.
Okay, so to finish the demo section, I wanted to talk about something.
Can you make it a little larger,
yes,
Raul,
okay.
your text?
So to finish the demo section, I wanted to talk about something we recently added to Kube-burner, which is what we call the OpenShift wrapper. As we have said initially, Kube-burner was initially designed to work against Kubernetes clusters, but we all know that OpenShift has some nuances with respect to a new Kubernetes cluster, and this is what the OCP wrapper is trying to address. So the OCP wrapper basically is a new thin wrapper on top of Kube-burner that basically automates some stuff you will have to make manually in a vanilla Kubernetes cluster. These kind of things are, for example, obtaining a Prometheus, a valid Prometheus token, and also discovering the Prometheus endpoint of the cluster. So you don't need to specify it when you execute Kube-burner. Also, apart from that, let me explain. The OCP wrapper is just visible with Kube-burner space OCP help. This wrapper includes some well-known workloads we the performance and scale team use in a day-to-day work basis. So I'm going to go through some of these workloads. So we have the cluster density workloads, which are basically workloads containing a variety of objects like deployments, image streams, builds, services, and even routes. And so the goal of this workload is basically to stress the API and the SDN components. And thanks to that, we should be able to, we have been able historically to detect perforations like memory leaks, some mistaken code optimizations, and things of that style. Also, we recently included a CRD scale, which is a workload meant to create a specified numbers of CRDs. In our documentation, we stated that we support up to 12 CRDs in a single OpenShift cluster. So this workload is meant to periodically test that the number is not mistaken more easily. And also, apart from that, we have the node density workloads, which are workloads meant to fill the worker nodes with the maximum amount of pods with the maximum amount of pods supported by that node. We recently, a colleague of us from the group recently posted created an entry in the OpenShift blog series, stating that we have tested up to 2,500 pods per node, and for that testing, he used a node density heavy workload intensively. So I think this could be a good resource if you wanted to test it by yourself in your clone cluster. So I'm going to execute a quick demo about how the OCP wrapper works and show you how the metrics are indexed as well. So to execute the workload, it's very simple. I just have to specify this command Kube-burner OCP node density. For demo purposes, I'm going to specify a Elasticsearch instance, and I'm going to specify an index name, which in this case is going to be Kube-burner, and I'm going to specify this flag as well, which means that that is telling Kube-burner to create up to, well, exactly 75 pods per node. So Kube-burner basically takes care of the math of calculating how many pods are currently running in the worker nodes and determining how many pods has to create. So if I hit enter, the party begins, and Kube-burner will start doing stuff. The first moment is taking some time because it's collecting some metadata that will index along with the metrics. As usual, it is going to print some of the configuration parameters like UPS and burst. It's going to specify the number of iterations it's going to execute. In this case, it's going to execute 177 iterations, which means with one pod replicas, which basically means that it's going to create 177 pods. And well, it's going to preload, basically giving some time to pull all the images from in the worker nodes, so the measurements are more accurate. And after all these stages, it starts the actual workload, and it takes just a few seconds to create 177 pods. Once it finishes the creation states, it waits for all pods to be running. So the measurements of both latency are completely taken, and starts indexing stuff in the Elasticsearch instance specified. Well, it also presents some quick summary about the pod latency metrics observed. So we can see here. Let me go through. So we can see that the pod ready latency 99 percentile was 15 seconds, and the average was 8,500 milliseconds approximately. And also it specifies the latency for other life cycle events of the pods, like initialize, container ready, pod scheduled. You have these life cycle events in the official Kubernetes documentation in case you're curious what does it mean exactly. And once it finishes showing all this stuff, it indexes the metrics and prints which metric is basically scraping from Prometheus, and how much time is taken to index the document into the Kubernetes search instance, and how many documents it has created. Okay, and at the end of it, it garbage collects all the stuff created, and that's it. Now, if I go to, I'm going to show you how would a Grafana dashboard using these metrics will look like. We can see that, observe that the UID of the round has been this one, A0, D, etc. So I'm going to copy it. I'm going to select my data source in my Grafana instance. I know that my cluster is configured with OpenShift SDN. I'm going to specify the node density workload, and I'm going to tell this drop-down button to show me the UID we just run. So this workload lasted just some seconds, and as you may know, Prometheus spread metrics on a 30-second basis. So for that reason, there's only one data point here in these metrics, which is not very useful, as you can see, because this workload only lasted around 27 seconds. But as a quick overview, we can see that, for example, we can open this row and observe what were the pod latency metrics collected. We can even go to pod by pod granularity and see what was the latency observed in every pod created during the workload. And also we have included some other useful metrics like master CPU utilization, memory utilization. That is to say, I mean, we are printing these metrics here because they are useful for our day-to-day work, but a user should be able to customize whatever he needs to collect the metrics he will need for a custom workload or other kind of work.
And this is a Grafana instance in our lab. Anybody is free to send it to any Grafana instance. Well, Grafana is in the lab and the OpenSearch instance is in the cloud right now, I guess. But anyway, the point I'm trying to make is you can send it to your own data store. You don't need to send it to our data store. So you're flexible enough to do that analysis yourself. But the important thing is if you want to do regression analysis and compare run to run, we do want that data to be stored somewhere. So that's why we ship it to OpenSearch or Elasticsearch and do the comparisons and analysis on Grafana. So that's the usual workflow of my team. So you'd see like Raul or Vishnu spending a lot of time on these graphs, analyzing stuff and making sure that OpenShift is scalable and performant and meets our customers' requirements.
Exactly.
Yeah, and which makes a lot of sense, right? Again, going back to we want to find and prevent regressions as we're going through. Sorry, my do not disturb just went off, so now everything is exploding because Jonny had to drop. So for anybody who noticed that Johnny's no longer here, he's over, I believe he's helping with the OpenShift Commons stuff, where they're going to be talking about validated patterns and all that. So yeah, I guess just a few more minutes. We'll keep on this topic. We'll close out a couple of things. So for anybody who is watching us live, please feel free to put any questions that you have into chat. We'll do our best to get those answered. If we don't happen to know the answers to any of those, Jonny and I are both part of the business unit and engineering, respectively. So we're very happy to go and find those answers, whether or not it's about Kube-burner, which of course this team here is the by far the most qualified folks to talk about that. But anything OpenShift related, we're happy to help with. Sorry to interrupt you there, Sai.
No, I was just going to say that was what we had planned for demos. We have we could take some questions, or there's a couple of other topics we could hit on, but the entire set of demos is on GitHub. Raul put them together, and I think that was shared on chat. So feel free to explore and play with Kube-burner yourselves, and you can engage with us on issues, just on GitHub like any open source project. So we have a very open model for development. And we don't do any separate tracking internally of features. So everything is taken from GitHub issues. So feel free to post there. And if you find any issues, let us know and we'll be happy to fix them.
Exactly. We also have worked intensively on trying to keep documentation up to date. The documentation is versioned, so every functionality documented in a certain version should be supported or should work on the given version. And
to add on top of it, like the Git repo itself has the documentation link from which someone can navigate to the documentation and explore for a lot many other options as well. With this demo, like we only due to the time constraint, we only had a restricted functionality that we could demonstrate, but there are a lot many other features which someone can explore and play around.
Yeah, we barely scratched the surface, so feel free to play with it and let us know what you find with it. You might be able to find performance ceilings or bottlenecks that we have not been able to find. So feel empowered to do that.
And everything's on GitHub, so you can just open issues against those projects.
Yeah, in the release section of the GitHub project, you should be able also to find binaries for different architectures like Darwin, ARM. So you can execute it in different variety of machines.
So I'm digging back through chat looking for questions. So Hasif asked maximum. Like, what is the maximum number of operators supported? So I think you said one of the metrics or one of the questions in the slideshow that was answered was like, what's the maximum number of CRDs?
So operators is controllers plus CRDs, right? So we can approach it from the lens of CRDs. I think we had some very recent testing to even take up the number of CRDs to 1,000 plus. We don't think we have updated the docs. I'll have to circle back on that one. But again, what we test is not what is the absolute maximum, right? Kubernetes scalability is in multiple dimensions. If you want to go further in one direction, you may need to compromise on some other dimensions. So always keep that in mind.
Yeah, and operators, like you said, it's more than just a CRD, right? OLM is going to be doing a lot of lifting there, and what is, what's its limitations and stuff like that. I would assume we'd have to check with the operator lifecycle manager team in order to get a definitive answer on that. Let's see. Peter asked about if this would ever become a supported offering from Red Hat.
I think I answered that on chat, but I'll reiterate. We are a performance and scale engineering team. We are not software developers per se, but we do our best we can. And to make this a supported offering means we need a dedicated software engineering effort, which we don't have bandwidth for right now. So our model is your mileage might vary, and we have numerous instances of customers running Kube-burner, even in their environments, and sending us data to our Elasticsearch, right? It's not a very scalable model, but we just don't have the headcount to support it right now. One day we may, and we'd be happy to do that then.
Yeah, I always tell folks, if that is something you're interested in, work with your account team and ask them to open, an RFE or open an issue with, internally with Red Hat. And then we can associate customer data with that. And effectively, the more customers we have that are interested, the easier it is to justify those resources. As I said, get resources assigned to be able to do all those things. So definitely work with your account team if that's something you're interested in. And then Murali, apologies for butchering names. Can Kube-burner be used for a continuous load and unload over a period of time? Which I think you had also answered that one in chat or in text there, Sai.
Yes. So Raul went over the cluster density scenario, and one of the features that it has is a churn feature, which is to mimic a real cluster. Instead of just loading up in an instant and unloading in an instant, it churns a certain percentage of namespaces created, creates deletes for a set amount of time. So I guess that's what you're asking for. So it exists.
Yeah. So one thing I wanted to ask is, so Kube-burner, and I pointed this out up front, it's a framework, right? It's an orchestrator for deploying workload. It's not explicitly for application performance testing. Rather, it's focused on the Kubernetes aspect and how Kubernetes is being affected, which is not to say you couldn't use it to test an application, and scale that application up and see what happens and all that other stuff. It's just, that's not the primary use case, I think.
Right. I'll give you a good example here, right? So Andrew Collins is an engineer on my team that worked on the 2,500 pods per node blog, which was shared in the chat recently. And one of the workloads he used to drive the entire exercise was called node density heavy, which is an actual scenario within Kube-burner that I believe Raul put together back in the day. What it has is an application pod that does some computation and comes up with a Euler number or something, and a Postgres pod, right, which is fronted by a service, and the application pod just puts that data into that Postgres pod. So we do actually run applications through Kube-burner, but like you said, the intent being what does the application do to the platform and how can we support the application? We're not really concerned about, how long it takes for the entry to go into the Postgres database per se, example.
Yeah, that makes sense.
Yeah, as I said previously, it is possible to specify Kube-burner to scrape the user workload monitoring stack. So if, for example, you have some custom application exposing some metrics endpoint, you should be able also to collect the metrics from your application in case you want to test it massively in your large scale in your cluster. So yeah, it's just a matter of thinking and iterating and starting from the simple minimum idea and evolving that idea to something useful to your needs.
And also, like when it comes to application testing, just to add on top of like what Sai said, we already have node density heavy, which kind of creates a simple app and scales it up to create the performance and load test. But also, like a user can specify a custom application because requirements vary. Like some people wanted to test a Java application, some people wanted to test a low level like C compiled application. They can just containerize it and then specify it as a object in their configuration and then specify iterations on top of it, so that they can have their have the minimal configuration specified over there, which will scale up to the bigger size of the application, and then they can collect metrics on top of it. So that's the main flexibility aspect of Kube-burner, wherein everyone can specify workloads and specify the applications according to their requirements and do run tests on top of them.
Yeah. So I have a whole bevy of questions. So is this something that you would recommend or you think would be appropriate to kind of have continuously running in the background of a cluster? Kind of keeping up with the, hey, I want to know if something changes inside of my cluster. I've got these namespaces that are running my production workload and these namespaces where Kube-burner is, just banging up against, the API server and etcd and all that other stuff. Does that seem like a good idea?
Looks like the curveball is for me then, because Raul and Vishnu are silent. So there are multiple facets to Kube-burner, right? The indexing, the measure part of it, where you can tell Kube-burner, this is the start time, this is the end time, go and get metrics for that. I can definitely see that being useful for analysis. But I wouldn't run Kube-burner continuously on a production cluster, right? I would do it to baseline once you build it and see what you can expect, and probably do it on dev and test clusters. But look at the name, Andrew, Kube-burner.
Yeah.
Do you really want to burn your cluster in production?
Like,
What happens if you encounter one of those, oh no, it broke something, and it's your production cluster.
why would someone run a load test continuously? It's not similar to a continuous profiling tool, which continuously monitors on top of the cluster. So it is something which creates load, and I don't think like this will be useful to detect regressions on a continuous time period of time. Like instead of triggering and using a load test tool, like I would recommend to go ahead with the monitoring tool, in order to detect regressions and spikes over a period of time.
Yeah,
that reminds me of something very funny, Andrew. I remember seeing a customer BZ open, and it was not the customer scenario being explained as to how they hit the bug, right, or the issue. It was like, hey, I ran Kube-burner with these parameters, and I couldn't scale past so and so. So we even have instances of customers opening bugs based on Kube-burner. Again, like we'll do our best to support the customers, but is it a realistic use case? If somebody wants to run 5,000 pods per node, Kube-burner will spin it up for you, but we're not gonna, say that, hey, this is something we'll go out and fix there. It depends on your environment.
Absolutely.
And also, good thing about Kube-burner is like if you already have a workload run, which is in a previous timestamp or on a previous day, you can just mark those timestamps and feed it as an input to Kube-burner, which will just scrape the metrics at that point in time, like to understand the behavior of the cluster on that point in time without running any actual workload. So we can do that using Kube-burner, like if we wanted to, detect regressions over a period of time, or else something ran in past.
Yeah, and our Hope 9 makes an interesting comment here of, using it to periodically baseline the cluster just to check for, changes, improvement or decline over time, that type of stuff, in order to verify. I did have a thought of, I see kind of two important use cases, right? So one, of course, is baselining and just verifying, validating that, on day one, I can expect this type of performance, or this amount of scalability inside of the cluster. The other side is, I think, using that baseline in order to determine whether or not changes are going to have a positive or a negative effect. And this is something that I recommended all the time when I was a storage admin, right? Hey, we're going to go in and we're going to tweak this little setting and see what happens. I see Suresh, mentioning iSCSI there, right? Hey, we're going to change the on-tap iSCSI service and we're going to set this parameter. Well, great. Did it actually do anything? Did it help with what you were doing? So, those things of, I see periodically threads come through where people want to go in and they want to tweak etcd settings and, change leader election timeouts and all this other stuff. And it's one of those, like, okay, what are you trying to fix? Is that really going to fix it? And, let's actually test and validate that it's going to positively impact or result in the positive behavior that you want. So I think that's super important. Also, probably don't do that in your production cluster if it's already struggling.
Yeah, for example, this is a common thing we have found out many times. A customer, for example, stating that it has upgraded the storage layer to, for example, include NVMe devices instead of the regular SSD. For HDD, and the customer in this case wanted to verify what is the impact of having those NVMe devices in a real scenario, rather than doing synthetic tests or with FIO or using the old tools by HDD. So in that case, Kube-burner could be the ideal tool because it's going to basically test this hardware boost, hardware upgrade, and could help you to identify which SLOs have improved with that change.
Yeah, I think that was another term that was put in the slides. SLO, SLI, service level objective, and service level. Why am I forgetting the I?
Service level agreement.
Yes, thank you.
Yes, for example, for the node density test, we internally have defined an SLO of 5 seconds latency So every test that is supposed to go beyond that 5 seconds latency SLO, we consider it a failure or a regression. So it has turned out to be quite useful because that latency is an indicator that something not going well. That could be on the node side, the kubelet, the container runtime, or even in the CNI side. So, yes.
All right. Well, I am sad to say that I just got a message from my oldest saying that he needs to be picked up from school. So I think that means that our time needs to come to an end. This has been super helpful. It's really interesting to me to, one, see how the sausage is made, so to speak. And it gives me a lot of, not that I didn't already know this, but it gives me a lot of confidence and a lot of, just reassurance to know that y'all are working diligently behind the scenes. I said before that I've seen your presentations, and I love those presentations that walk through, hey, we tested, SDN performance, we tested API server performance, we tested all of these different things. And I think that's really awesome. So to our audience, so for anybody who is watching us live, we'll be here for another 60 seconds or so. Feel free to drop in any questions. We'll do our best to answer them, or we will follow up next week during the top of mind segment to answer any of those. You can also, of course, reach out via email or Slack or chat or any of those other things at any point in time. I think I have a shortcut here. No, that one didn't work. Come on. Well, I thought I had a chat shortcut that would actually post the link into the Kubernetes Slack, but it doesn't seem to be working. So instead, I'll go with our normal caption. So you can always reach out to us on the Kubernetes Slack. So kubernetes.slack.com/archives/ you see the URL there. I'm not going to go through all of that thing. One thing, if you are not already a member over there, just to show you what that looks like. So if I go here, because somebody sent us a message and asked this the other week. So if I go to kubernetes.slack.com, up here, if you don't already have an account that you can log in with, you click create an account and it takes you to this page. You see this thing right here? It tells you exactly what you need to do in order to get an account. So it says get an invite at, slack.kubernetes.io. And if I go to that URL, slack.kubernetes.io, you can see I just enter my email in here and it'll send me an invite, and that will get me a login over into kubernetes.slack.com. So that's that's kind of the big thing there is slack.kubernetes.io is how you get an invite to the Kubernetes Slack channel. All right. You can also reach out to us on OpenShiftCommons.slack.com. So that one does not have an inviter. We're trying to figure that out, but you can always, I think you can, if you're a member of Commons, you can ask them and they know how to send out the invites from there. And of course, email is always great. Andrew.sullivan@redhat.com or Jonny, Jonny @redhat.com. And with all of that being said, thank you. Really appreciate you all joining us today. It's been great having you on, and I left Johnny's name up there. That just means that everybody should send messages to Jonny. Jonny.
Thanks, Andrew, and Johnny's not here, but thanks to Jonny as well. Thanks for hosting us. This was a great opportunity.
Yeah, thank you for having us today.
Yeah, and thank you to our audience as well. It's been great having you all on. We love the chat. We love the questions and the interaction. Please don't hesitate to reach out to us at any point in time.
Yeah, thanks for the engagement.
Yeah, I'm looking at this chat. Let's see, Mr. Quadface and rhope9. Hey, storage admin, something is wrong. Did you do something? Yeah. rhope9, that was usually my experience as well. Something has changed and it's changed for the worse. What did you do? And we didn't do anything. It's fine. It's okay. So anyways, all right, my son is now sending me multiple messages. So all right, y'all. Thank you so much. We will see everyone next week. Next week, we will have Ortwin and Stelianos joining us to talk about Service Mesh. So be sure to join us at the same time here on Red Hat Live Streaming. Have a great week, everyone.
Bye, everyone.
Thank you. Bye-bye.